Good morning, everybody. I hope you enjoyed last time's or yesterday's evening event, and you're ready for another tracks. And we will start with Tarus Balog telling us something about OpenNMS 14. And enjoy.
Good morning. Guten Tag, buongiorno, bonjour, buenos dias. Yeah, my name's Tarus Balog. I'm one of the maintainers of the OpenNMS project. Has anyone here ever heard of OpenNMS? Okay, we've got a few. Anyone actually use it? So we have a few in the back. So I'm actually known as the mouth of OpenNMS. Did you ever see the Return of the King movie from Lord of the Rings? And at the very end, the guy on the horse comes out and he's got the very bad teeth. And he says, "I'm the mouth of Sauron." So that's me. I'm the mouth of OpenNMS. And I do blog a lot. I know I'm old because I blog, because everyone's now Facebook and stuff, but I blog. And one thing I want to address is Chris Botar has the monitoring sucks talk. So he was here yesterday. And I'm going to hope I can address how OpenNMS is different and why, at least when I use OpenNMS, I don't think monitoring sucks. So I don't know if it's quite monitoring love, but I don't think it sucks. So quick agenda. It's really weird coming to this conference, and I love this conference, but it's strange because we come here every year, and I don't know if you were here the previous year, so I don't know how much of OpenNMS I should talk about. So I thought I'd do a very quick overview of OpenNMS. And just about 3 weeks ago, we released OpenNMS 14. And I want to talk about some of the new features. Notice I have the words demo. So I was actually up very late. I think I've gotten all the bugs out. But I do have a live demo to talk about some of the features of OpenNMS. And then we'll take some questions and answers. And I'm here for the rest of the day, so if I raise more questions, you can go. So when I started with OpenNMS, it was in 2001. Actually, September 10th, 2001. Very easy day to remember, because on September 11th, 2001, we sat and watched television like everyone else in the world. So that, to me, was the 9/11 events in the United States was kind of the end of the first internet bubble. It probably started when Netscape went public. So that was, what, 99, and then it was great. Oh, if you could spell SNMP, you could make a lot of money. It was a great time to be alive. Bill Clinton was in office. It was awesome. But 9/11 happened, and that was a very, very bad time to be in business. I mean, no one was spending money. Everyone was scared. And so here I start my new job. I'm working for this company called Oculan, and they made a product based on OpenNMS. And they brought me on board to build a service business around the OpenNMS part. And so I was there until May of 2002, when two things happened. First of all, we released OpenNMS 1.0. Yay, 1.0 release. And the second thing is Oculan ran out of money. So they were VC, venture capital fund, and VCs say, here's a whole bunch of money, go spend it, and we'll see if you get lucky. And so they ran out of money, and the investors said, well, we'll give you more money. We'll give you another $5 million, but we don't want you to do open source. We don't like open source. Open source kind of sucks. Well, I saw the potential, because I had spent my life working with HP OpenView, Micromuse Netcool, Tivoli, all of these commercial products, and I'm like, it really sucked. My day would be, so I worked for a consulting company, and they would say, okay, go install Micromuse. So I'd show up on Monday, and we'd get the license keys, and you'd install Micromuse, and it was great. And then Tuesday morning, I'd find a bug. And I'd go, oh, crap, this isn't working. So I'd call up Micromuse, and I'd go, hey, I've got this bug. They go, oh, yes, we know of this bug. We fixed it. I'm like, great. Where's the patch? Oh, that'll be in 6 weeks. And I'm like, what am I supposed to do? They're paying me to fix this problem. And I said, oh, if we had open source, I could just fix it, and I can make it work. So I went to the head of Oculan, a man named Steve Giles, and I said, give me OpenNMS. And he kind of looked at his watch and said, if you're off my payroll by Friday, we'll give you some servers and we'll sprinkle water on you, and you're like OpenNMS now. That was the easy part. How many of you are married? I'm married. So if you ever decide to quit your job and start your own business, you might want to discuss it with your wife first or your partner. Because I was informed that this was what we call a we decision and not just a me decision. So we've been together 22 years, so we survived that. But anyway, so here I am. Now I've got my new business. I'm going to do OpenNMS. And someone said, you have to have an elevator pitch. And I'm like, well, what's an elevator pitch? And they say, well, if you meet someone in the elevator and they ask what you do, you have maybe 30 seconds to say what you do. So if I'm in the elevator and someone says, oh, what's OpenNMS? And I go, well, OpenNMS is the world's first enterprise-grade network management application platform developed under the open source model. Bing! So I'm like, ooh, elevator pitch. But I'm a geek, and I hate it when I say, we're the paradigm-shifting, synergy-building, cloud, Docker, Internet of Things, It's like I have to defend all of these words like world's first enterprise grade. And so I have some slides for this real quick. But so does anyone here remember SourceForge? It was GitHub for old people. So OpenNMS... Back in the day, if you had an open source project, you got an account on SourceForge. And so Ethan Galstead registered NetSaint in January of 2000. And he was project 1323. We were registered in March of 2000. So we were project 4141. There's Zabbix is on there. That was in 2001. Ethan had to change the name from NetSaint to Nagios in 2001. We've got even Asinga here in 2009, so they've been around for 5 years. So we've been around a long time. The project was actually started in 1999, but the first code was released on SourceForge on March 29th, and that's considered our birthday. So next year we turn 15. So we've been around for a while. Now when I say enterprise grade, we started off to manage tens of thousands of devices. And ultimately, we want to manage millions of devices. And so these are actual paying customers. There's a company called Swisscom Hospitality Services, and they were monitoring 63,000 discrete devices with one instance of OpenNMS. There's a company called New Edge Networks. They're now owned by Earthlink, and they're doing 1.2 million data points every 5 minutes. There's a company in Italy called Wind. They use Juniper equipment. The devices have 320,000 interfaces. Virtual, of course. They're not like physical interfaces. But they have 320,000 virtual interfaces per device. You point HP OpenView at that, it can't even discover it. It just sits there because the IF table, it just can't handle that. We can. We didn't at first. But when we started working with Wind, we fixed that. One of the cool customers is the Savannah River Nuclear Solutions. This is the company in the United States that makes our nuclear weapon fuel, plutonium. And they use it to monitor syslog events. And they're monitoring 2,000 events per second, 24 hours a day. And then Papa John's Pizza. I don't know if there's Papa John's I know it's in the UK. But it's a big pizza chain. They're in China, so it's kind of cool to be in China. They actually have 4,000 remote monitors. So we have a little piece of OpenNMS code in every Papa John's store. They sell $1 billion worth of pizza every year online. And so they have to make sure that the store that makes the pizza gets the order, because the order goes into the data center in Louisville, Kentucky. And if the restaurant cannot communicate with the data center, they can then pick up a phone and call in orders or bring up an ISDN backup circuit or something to make sure that works. So enterprise grade. Now here's where the whole monitoring sucks thing comes in. OpenNMS, I never think of OpenNMS as a platform. As a program, like an application. It's a platform. Sure, you can take OpenNMS, you can do yum install OpenNMS, apt-get install OpenNMS, and start it up, and you can use it. And it does good things out of the box. But where it really shines is when you customize it. So saying monitoring sucks in the context of OpenNMS is like saying PHP sucks, or Python sucks, or Java sucks, or Excel sucks. I mean, no one goes, oh great, there's a new MySQL. Unlike World of Warcraft. You know, World of Warcraft, they come out with a new expansion pack and everyone gets all excited. Ooh, new expansion pack. But with a tool, you get excited about what you can do with it. And I'm going to show some examples of how OpenNMS is kind of different from a lot of other applications. And then finally, we are open source. Every piece of code we write is available under an open source license. We recently switched to the Affero GPL version 3. We coined a term in the US called FOPEN source. I think the correct term is open core, but to me it's fake open source, FAUXPEN source. When you say, oh, we're open source, oh, but you want that feature? Well, that's in the enterprise version. And it used to bother me because I'd go to conferences or trade shows and they'd say, oh, this is great, but how much is your enterprise version? And I'd say, we only have the one version, and it's our enterprise version. You know, that's what we do. It's open source. So enough of that. Okay. If you type open source network management, I did this just yesterday. If you type open source network management into Google, we're the #1 hit that's not an advertisement. These two are ads. We don't do anything special for that. It's just we've been around for a while. Usually it's not Xenos. Usually there's Wikipedia is next. But I don't know how long that'll last. It's been going for about 10 years now. If you type open source network monitoring, we're on the front page, but we're not the #1 hit. So a lot of people at least refer to us as a network management tool. There are 4 main areas of OpenNMS. So the heart of OpenNMS is our event management system. Did anyone here, have you ever worked with like Micromuse Netcool or even heard of it? I mean, Micromuse Netcool is to get started. If you wanted to just get the bare basic system, you're talking $100,000. I worked on a install for cable and wireless that was $2.2 million in license fees. Think about it. It's like you give someone $2.2 million US and they send you an email with some numbers. I mean, go download it, plug these keys in, and you've got Micromuse. And so the heart of OpenNMS is this publish and subscribe message bus. And we can do tons of things with events. What we're going to demonstrate today is this thing called alarms. So events is like your log messages where you can pick out events and say, ooh, I want to actually be alerted on this one. And I want to do correlations. And I want to do notifications. We can do event translation where you can actually take one event. Like if you've ever gotten an S&P trap for interface down, the only variable binding you get with an interface down trap is IF index. So it's like, oh no, IF index 7 is down, not IF index 7. What we will do with OpenNMS is we will take that event, look up what IF index 7 is, and then tell you that this interface on this node is down instead of just IF index 7. But it's very, very powerful. Provisioning. People don't think that much about provisioning, but when you're dealing with 63,000 devices, you have to have a way to tell OpenNMS what to monitor. You're doing moves, adds, and changes all the time. So you can have some kind of canonical inventory system and then tell OpenNMS what to provision. We do automated discovery. I mean, you can do just like every other tool. You can say, start pinging with 172.20.1.1 to 127.2.1.254 or whatever. You can do that as well. But we have a very strong provisioning system. Almost everything we deal with in OpenNMS is also available via REST. Is there anyone here relational state transfer? It's a way of using HTML. You do posts and get to change things. So I can access almost everything in the database and everything in the provisioning system with a REST command. So at a lot of our customers, they don't even use our GUI. What will happen is they'll come in and say, oh, well, we've just added this new device. They'll send a command to OpenNMS to provision it, turn on monitoring, turn off monitoring, delete it, etc. We do performance data collection. So this is kind of like your cacti, your collect D. Currently, our backend is RD tool. There are some issues with RD tool, as you probably know, as far as disk I/O. We have a new product that I'll talk about called NewTS, which should solve all those problems. But the beauty of this is, again, you're not writing any kind of script or anything. You literally just go into configuration and say, I want this object ID, and it'll go out and collect it. So if there's one Windows box that I want to collect these metrics on, that's fine. If there's 100, I don't have to do it again. It'll automatically go and say, oh, this is a Windows box. I need to collect this data from this Windows box. Lots of different protocols, SNMP, HTTP. I have the drink machine. I bought a vending machine for our office, and I have it hooked up to the network. And so anytime someone buys a soda, like you have just sold a Diet Coke, I get a notification. So it shows up and it says, so it's funny because I know what people drink. So like Matt drinks Diet Pepsi, Ben drinks RC Cola, so it's kind of funny. I track my eBay auctions using the HTTP data collector. We have thresholding, of course, just like every tool, but in addition to high thresholds and low thresholds, we have relative thresholds. Let me know when it changes by a certain percentage, and we have absolute thresholds. So for eBay, I say, let me know when my auction price has changed by 1 penny or more. And then I get a notification, oh, someone bid, and my new bid is this. And then finally, service assurance. This is your check scripts, which is what I guess, I'm assuming that since everyone here is usually from a Nagios background, it's very much like that. So at the very end, we say, to us, everything's a service. So if I can ping a device, it's providing the ICMP service. And so that's our low-end service check. And we can connect to a port, is something listening on port 80. But we can go up to, we have a mail transfer agent, which will say, okay, send an email and make sure it arrives. We have the page sequence monitor that will actually go page to page to page and fill out forms and make sure that you can actually log in and log out of pages. And finally, have you ever heard of Selenium? It's a test suite for web apps. We have a Selenium plugin. So you use Selenium, you create this XML file, you plug that into OpenNMS, and it'll run the Selenium test for you. So those are the 4 main areas. Now we've got reporting, we've got an integration with Jasper reports, we've got trouble ticketing interfaces, we've got a whole bunch of stuff. When I teach the course for OpenNMS, we spend 5 solid days, and we still don't cover everything. So again, if you have any specific questions, just find me after this talk. This is just a really quick slide this is the architecture. At the heart of OpenNMS is a process called Event-D, and this is our publish and subscribe message bus. So everything's kind of driven on that. I'm not going to go over this slide, but what I wanted to point out is that it's very modular. Like we started out using RRD tool. And then we found this project out of Bosnia called JRobin. We're a Java app. Everyone hates Java, right? Yay, Java sucks. Okay, we've got a few Java sucks over there. Again, I didn't make the decision to write it in Java, and I do everything through configuration, so I never really mess with Java. But so we are written in Java, so we wanted to use this Java port of RD tool because at the time it was faster. So we just have a new strategy. So you can use RD tool natively with the RD tool strategy. You can use the JRobin strategy. We've got this new strategy called NewTS. And so it's very, very easy to go and collect all this different data. We have an integration, a map integration. We did this for Papa John's, and we just assumed they use Google Maps like everybody else. It turns out they use MapQuest. So if you go to Papa John's, find my nearest store, you're going to use that. They pay a lot of money for that. So they had a license. So they said, we don't want to use Google Maps. So we used, so we have a strategy. So you can use the Google Map strategy, you can use the MapQuest strategy, and of course, you can use OpenStreetMap as well. So we have the OpenStreetMap strategy. Now, so 3 organizations I want to talk to you about. First of all is OpenNMS.org. We strive very, very hard to separate the open source community from the business. I don't sell to my community. I don't market. I really hate Xenos. Not necessarily the product, but the whole, we're open source and then suddenly we're not open source. And if you go to, it used to be if you went to Xenos.org, it took you to Xenos.com/community. And you had the community edition. I hate that. So OpenNMS.org is managed by our community. There's a core of about 40 people called the Order of the Green Polo. the T-shirts that we have, like this gentleman's Izod shirt, we call those polo shirts. And you can buy like white ones or black ones that have OpenNMS on them, but you have to earn the green one. And so we have the Order of the Green Polo. This was our information. We had 58,000, almost 59,000 people come to OpenNMS last month. So it's a very busy project. We get about 5,000 to 6,000 downloads a month. And this is OpenMS.org. We've got a wiki. There are some gentlemen who've just spent a lot of time updating, believe it or not, our documentation. We actually have documentation now. I was told by someone, he was very angry, he says, the only thing worse than not having documentation is having wrong documentation. So we have gone to try and make everything very, very current. Now, the reason I was able to fly here is this thing called OpenNMS.com. And this is the only OpenMS.com slide I have, but we provide services, support, consulting. That's how we make our money. So kind of like Red Hat. But again, everything's open source. And of special interest to you folks is OpenNMS.eu. There is a foundation, a non-profit actual corporation registered with the European Union called the OpenMS Foundation, and they have a conference every year, kind of like OSMC, but just for OpenNMS. We're waiting to determine when it'll be in 2015, or where it will be. Right now it might be Fulda, the big metropolis of Fulda, or Paris. They're about the same. Just one's German, one's... No, Fulda's very small. I like Fulda, though, don't get me wrong. But you can become a member of OpenNMS.eu, and you vote, and there's meetings, and there's a lot of good stuff coming out of there. So we actually have our own little foundation, which I think is kind of cool, because I didn't do that. Okay, OpenNMS versions. We're getting to OpenNMS 14. We're one slide away. We used to follow the kernel. Remember the kernel used to have, they'd come out with kernel 2.0, and that was the stable kernel. And then they'd come out with 2.1 was the development kernel. And when they felt it was ready, they would announce 2.2. So that was us. So we had OpenNMS 1.8 was a stable version. And the moment we did 1.8, we would tag 1.9. And that would be our development version. And we'd work with that. And then at some point in time, we'd release a 1.10 and then start a 1.11. We don't do that anymore. We pulled a Java. Remember, Java went from Java 1.6 to Java 7, or 1.4 to Java 5. I forget what it was. But now we just said, okay, look, we've been doing this for almost 15 years. We need to release it. Call this 14, and the next release of OpenMS will be 15 and 16, just like Firefox, just like Chrome, just like a lot of projects now. So now we're on OpenMS 14. One of the reasons we want to do this is more frequent releases. We do a stable release about every 18 months, and we'd like to make that more like every 6. And so we're hoping that with this, that we'll be able to do that. OpenMS 14 is awesome. And I say that because I'm going to point out a big bug that I found preparing for this demonstration. But I'm very, very happy with OpenMS 14. We put a lot of people on it for several months to make sure that we fixed something like 2,000 small bugs. You guys understand code debt. It's like you're trying to get something out, so you get, I'll go back and fix that later, and you never do. Well, we spent a lot of time fixing that we were supposed to fix later, so I really, really love the way OpenMS 14 looks. A lot of it had to do with visualization. How many people like network maps? Right? You got to have the big map, right? Do you guys use NAGViz or Network Weather Map? I hate maps. And part of the reason was back in the bubble days, so 1999, as I said, I'm old. So back in like 1999, I got paid, or my company got paid like $250 an hour for me to drag icons around OpenView maps. Because the guy wanted that, the NASA, ESA, the map with all the world and stuff. And if you did that, if you added a new device, it would end up at the bottom of this little container, and you drag it, and there'd be a link, and say, oh, that goes there. And so you sit there and drag them in. And then once you were done with that, you'd click on the map, and then in that map, it would be more. And you'd have to do that 4 hours a day. I spent 4 hours, because they were a DSL provider, so every night they'd turn about 300 or 400 devices on. And there was no easy way to automate. I hate maps. But we actually have a really cool map now. So we have a couple. So this is the demo portion of our program. Here is our wonderful GUI. Said most people don't use it, but I'm going to go up under here. We actually have 4 maps. I don't have one set up. We have a distributed monitor map. So that Papa John's, where they have 4,000 distributed pollers out there, I don't have that configured on my little tiny XPS 13 that's 3 years old. But one of the things we have now is this geographical map. So I'm going to go to the geographical map. And this is, I believe, OpenStreetMap. So this is a database that we've taken from one of our clients, and then we've gotten rid of all the identifying information. But so if you look here, there's 9 devices over here. There's 15 up here. There's 32 here in Washington, D.C. If I zoom out, if you mouse over, you can see kind of the area it's included. But as you saw, when I zoomed out, it took the 15 and the 9 and it combined them. So you can actually zoom way out. And now it should actually eventually bring that together. But I went out a long time before it did. So maybe it doesn't because of that. Again, it's a demo, yay! But we have some customers which have a lot more, and it's kind of cool. But if you mouse over, it kind of shows you what area is included in each one of those. And all you need to do for this map is in the asset table, you just simply put an address. And then we have a geoencoder that will look up the latitude and longitude and put that in there. So all you do is just put that in. It'll automatically put it on the map. It does not show links. So if I drill down, here's all the different nodes that are in there and what the statuses are. I don't see any links between the two of them. The geographical map does not do that. But it does show you all the different things here, and you can see alerts and things like that. So I'm going to somewhat cheat, and I'm going to run this little script where I'm going to cause an outage. Whee! Basically, I just updated the database. So if I go here, so here's OpenNMS. Now we can see we've got an outage. So here's all these alarms just popped up. And so I'm going to go and click. So remember, events are the event bus. So that's like syslog. That's just, there's tons and tons of events. But we've decided that if there's an error, like in this case, I'm going to go and click on this alarm here. If there's an alarm, here we have an interface down alarm. Well, that's an event that we want to notice. Now, alarms do a couple of things. First of all, you see there's this count. When you set up an alarm, you actually configure this thing called a reduction key. And the reduction key, all it is a string. And you basically say, if I get an event with this reduction key, it'll turn it into an alarm. And if I get multiple events, instead of having multiple lines, it'll reduce it and just up the number. So here's the reduction key here. We have this thing called a UEI, Unique Event Identifier. It's literally a string. All events in OpenNMS are associated with a UEI. So when we get SNMP traps, we convert them into events with a UEI. If we get syslog messages, we convert them into an event with a UEI. So in here, the reduction key says, well, let's take the UEI, which is interface down, add the node, which is node number 10, and the interface. Excuse me. Because this is fake. David faked this. There actually should be a node number in there. But if I get another event with this information in it, it'll just increase the count. Now, if I go down here, there's some cool stuff. We have these little fields here for memos. So we have a sticky memo and we have a journal memo. So what do you call, they're sometimes called Post-its, the little yellow pieces of paper with the adhesive on them. So we call that sticky. And so this is a sticky memo, so I can type in here, it says, I'm working on this, I think it is a cable cut or something like that. So I can save that, and that tells me I've got a sticky memo. And then the difference between a sticky memo and a journal memo is, this happens when it rains, or something like that. The journal memo is associated in the database with the reduction key. So every time this alarm happens, if I clear the alarm and it goes away, when it comes back, the journal memo stays there. The sticky memo is just for this instance. So this is kind of, I'm working on this now. When this interface comes back up, this will go away. But the journal memo will always stay there. And so I'm going to acknowledge this alarm. And so it tells that I acknowledge the alarm. And if I go to the node, so here's the node page. So here's all of the information on the node, all the interfaces are on the node. Here's some of the messages, etc. But the cool part is I can view it on the topology map. Now the topology map is different from the geographical map. This shows how things are related. Whee! And so I'm now looking at this map where my focus is on this device right here. And so it's right up there. And I can see that because of this outage, there's a node that's down. So it's this node here. So I can actually right-click on here and say Add to Focus. And when I add it to focus, notice now I have just the part of the map that I'm interested in. Now there's something like, in this demo, there's something like 700, I got to get a bigger laptop. There's something like 700 devices. So what I want to do is I want to increase the number of hops. And so that isn't very useful. I mean, especially, I mean, we have customers with 7,000, 8,000, 9,000 nodes that use this map, and you get little bitty dots. So what we've done here is try to create a topology map that's actually really useful, that allows you to zoom in on exactly what you want to see. And the part that's broken is I can choose this marquee select, and I can do that. And what that will do is just limit the number of alarms that happen to be on those nodes. And I could group acknowledge them. I could hit select all and acknowledge. That doesn't work right now. It used to. But so we'll have that fixed in the next point release for sure, because it's a big problem. But I discovered it yesterday while I was playing with this. The cool part about this is what we call our link D. So link D is a process that connects devices at the layer 2. So it goes through and looks at bridge tables and finds out where MAC addresses are connected. We have other topologies. I don't have one I can show you. Ronnie Trommer is in the back there. He's from. He was originally going to give this presentation. We don't use VMware, but we have in my office. But they do at the University of Fulda, and so we have a VMware view, which actually shows you host, guest, remote storage, so you can see different topologies. Anyone here use Juniper equipment? Juniper gear? No Juniper. You do a lot of cool stuff. You get your hands up. Keep looking back there. Juniper licensed OpenNMS to embed in Junos Space, and they've created their own topology view, which shows all the PVCs and all the different connections, because they know that data. And because of the API that we have, you can add new topologies. So we hope as time goes by that you can visualize your network. So you've got your geographical visualization, and you've got your topological visualization. So anyone think that's cool? I think that's cool. And I'm going to go ahead and let's clear the outage. Refresh. It would automatically refresh in a time, but you can see now that the outage has been cleared. So that's one of the visualization things we've done. We also did this thing. Let me go back to my presentation. There's this cool thing called it's an ops panel and a wallboard. And the internet here was kind of flaky, so I didn't know what to do. So Ronnie helped me with a little video. So I'm going to play this little video. I can't embed it because it does weird things. But basically, you can go into OpenNMS and you can put in like even links to Dustern here. I actually have that watch. That's my watch. And then you can also do what's called a wallboard. So you have your operations board where you can put various OpenNMS pages, or any other page. So if you have other tools that you want to put, you can all put it on one single pane of glass, or as a person told me, one single glass of pain. But the wallboard is something that rotates. So if you have a screen in your NOC that you can just rotate, so it'll, you have interesting pages, you can either display all of them at once, or it'll actually go through and rotate through the pages. So I think that's kind of cool, For a company that we're not really known for our visualization, our GUI isn't as it's not all, it's getting better, I should say, it's getting better. But you can go in and load, here it's loading a map. It's not loading very fast, but it's where we dance. And so there's one of the maps that we have. You can do alarms, etc. Anyway. So is everyone good with that? Whoops. There we go. So now, so I've been going for, what did Chris write? Oh, he's on Twitter. So I've been going for like 40 minutes now, so I think I have enough time to finish this. I wanted to demonstrate, I'm like, how do I talk to you guys who come from Nagios? And I'm not, as long as you're using an open source management platform and it meets your needs, good for you. I'm not, OpenNMS isn't better than Zabbix, it's not better than Nagios, it's not better than Asinga, it's not better than Sensu, because everybody's different. We meet the needs of our clients pretty well, but in other shops, they don't meet, they're much happier with other tools. But just open source, please don't buy proprietary tools. So I wanted to say, what is something that could demonstrate kind of the philosophy that we built with OpenNMS? And I came up with this demonstration. We did a big project in Sweden last year. So I spent a lot of time in this huge city called Mellerud. Actually, the city was Olsensbrook, which was 500 people, and you drive 10 kilometers to Mellerud, which is where the restaurant was. So it was a very beautiful, beautiful place, but it was in Nowheresville, Sweden. And the NOC came to me one day and said, we had a problem. We have these scripts that run every day, but we need to know when they don't run. Now, it's easy to do, I've had a script with an error, but how do you measure something that didn't happen? And I guess you could have scripts write a file, and then you can go and do a check on did the file get updated every 24 hours or something like that. But it's like they had a lot of scripts with different names and things like that. And so I said, okay, I'm going to use our alarm subsystem to fix this problem. Now, as I mentioned, alarms take events, and they do two things. They take similar events, and they do what we call event reduction. Because Micromuse used the term deduplication, and we're totally different. Don't sue us. We're totally different. Event reduction is nothing at all like event deduplication. And then we can perform some correlation. Most of the correlation in the alarms subsystem is done basically by manipulating SQL. We do have a more complex integration with a tool called Drools. Anyone ever heard of the Drools project? It's part of JBoss and then part of Red Hat now. Drools is amazing. We can do very, very complex correlation. But it's a lot more, it requires a lot more understanding of, it helps to understand Java a little bit more, and I don't. So I really like alarms. So I'm going to show you how we can do an automation to let me know whether or not a script has actually run or not. So automations consist of three things. One is a trigger. And as I mentioned, I have examples of this, but a trigger is, has a condition occurred that I need to take an action on? Because if one of the things that automations can do is match an up event with a down event. Well, if I don't have any up alarms, there's no reason to check to see if I can fix the downs. So the trigger might be check and see if there's up alarms. You have to have an action. It turns out in this example, I had two automations that didn't require an action. So we have a do nothing action, but you have to have an action. And then finally, you can generate an event. So if you have an automation, you can generate new events. And so I'm going to just kind of demonstrate that. Okay, the first thing, OpenNMS events. If I want to send an event into OpenNMS, it's really easy. So let me bring up the GUI. And as we see, if we go to OpenNMS, I cleared all the outages out. So I'll go to Events, All Events. And what I'm going to do is, does anyone here familiar with this really ancient language called Perl? We have this thing called Perl, and we have a little script, and I'm going to say uei.osmc. So I just sent an event into OpenNMS. So if I refresh here, there we go, it's down here, because there's other stuff going on. But, here's an event with no matching configuration was received from interface blank, because I don't have it. If I click on that, we'll actually see, there's the UEI right there, uei.osmc. So I just created a UEI. All this does is, if you look at the Perl script, which is very easy, and we've got versions of it in Python, PHP, Java, and what it does is it connects to port 5817, and it dumps some XML. And assuming you have the ability to connect to port 5817, you can send events into OpenNMS. If I send it, I can send it a couple of times. So let's go, let me send, so I sent it 5 times. Now when I can go here, refresh, didn't hit refresh. So here's some more of these events. If I go to alarms now, that actually is configured as an alarm. So I had an event with no matching configuration was received, and the count is 5. So that's one of the things alarms does. Now, what I'm going to do is I'm going to create 3 new events, and we do this in our office. So we have a script started event, we have a script finished event, and we have a script error event. So we use duplicity to back up to the cloud. So, and I know that Chris is talking about you don't use cloud in Europe. Well, we back up everything encrypted. Duplicity allows you to encrypt on the fly. It's basically an rsync kind of thing. And so every day we run our backups, and so we get an event into OpenNMS that says, hey, the backup process has started. Anywhere between 30 seconds and 30 minutes later, I get a backup has finished. So I know that backups have run. If there's an error, if we ever exit, I send another event in, and this generates a notice. This will send an email or a page, and this will say, hey, backups failed for some reason. So that's the first thing. So I have to instrument my scripts. So I went to this customer in Sweden and said, okay, whatever language you're in, let's write a little thing that can connect to port 5817 and say, script is started, script finished, etc. So here's my automation. Did this script run? So the first thing I need to do is check to see, I need some sort of alarm that tracks the event. So let me go over here. I think my timing is going to be off, so I apologize in advance for that. But I'm going to send this event in. And so if I look at my alarms, so I have this script, important script has finished normally. So I got this alarm that came in. I passed the name of the script as a parameter. So if I wanted to do another script, if I was on another machine or I had another script, so I'll send that in. Now I have, did I hit refresh? I'm missing that button. So now I have script, another script has finished normally, and a script, important script has finished normally. So those generated alarms. Now I've created an automation that creates tracker events. So you see here that the script runs about every 30 seconds, and it says, I need to create a tracker event to track whether or not this script is run. So if I hit refresh, I should have four events now. So here's my tracker event for another script. Here's my tracker event for important script. Do you guys see that? So the way that worked is, so I needed a tracker alarm. So the trigger is, let's see if there's any script finished alarms that don't have a tracker. And if there are, let's create them. And so it's all XML. I'm not going to get it. I assume you guys can either figure out XML or mess with it. So you go into a configuration file, and I created my automation called generate tracker. It runs every 30 seconds. Time in OpenNMS is always in milliseconds with one exception. So there's 30 seconds. It's active, so it's true. So the trigger is going to be select finish scripts with no tracker. So here's my SQL. And this is what I've struggled with for like 4 hours yesterday to make sure this would work. But basically, I'm going to select from alarms where the event UEI equals script finished, and there doesn't exist a script tracker event. That was the hard part, because I wanted to embed in the reduction key, which is that string that reduces it, the name and node that produced the script. Because if I have, the first node we discovered just gets labeled node 1. The second node is node 2, et cetera, node 3. So if I have 10 nodes all running the important script, the reduction key will be the node number that ran the script and the name of the script. And I need to make sure that those are treated uniquely. Otherwise, I'm not tracking the script running on every different machine. So I'm not going to go over this, but because you can get a copy of the slides, but it's lots of regular expressions. But this basically says, if there are any finished events that exist without a tracker event, then that'll trigger if I have one row, if it's greater than or equal to 1. So I could have one event, I could have 200 events, I could have 0 events. If there's 0 events, nothing happens. But if I have at least one event that says, hey, I've got a script finished event without a tracker, then we're not going to do anything. This is our do nothing action, but we are going to generate an event. So we're going to create our new event called the script tracker event. And we're going to assign the same node ID, the name of the script, which is in this parameter, the alarm ID that caused this new one, and the alarm event UEI. We'll pass that all as parameters. So now I've created my tracker event. Now, so I've got a tracker event. What I want to do is say, so let's say I want these scripts to run every 24 hours. In this example, I have it set for 3 minutes, so because I don't want to wait around 24 hours. But what happens is every time I get a new script finished event, I want to go and update the tracker event. Because I want to say, hey, it ran. So every day the script finished event runs, and every day I want to update the last event time of my tracker event so I know that, hey, it ran. And so here's our new automation called update tracker. There are no events, because we're just going to modify some XML, some SQL. So what we're going to do is see if a new script finished event has arrived, and if so, let's update the last event time of the tracker. And so here's my trigger. Is there a script finished event? And if so, I want to go and update the corresponding tracker event. Again, this was a pain in the butt to figure out from SQL, but I did manage to get it to work. I want to demonstrate that in a second. And so this will update the last event time. And then finally, we want to see if the tracker has been updated. If it hasn't been updated in 24 hours, we want to generate an alarm that says, hey, the script didn't run. And so we select all the open tracker alarms and then check to see if they've been updated in a certain period of time. And if so, don't do anything, don't do any SQL, but just create a new event that said the script didn't run, which will cause the script didn't run alarm. So again, here's how we select the trackers that haven't run, and then we generate the did not run event. And the way we do it here is we have an interval. Here's where you'd put in like 24 hours. Now, I struggled. I spent maybe 2 hours yesterday trying to figure out if I could pass another parameter and make this a variable where I could pass the time. I can't. Postgres just doesn't allow me on that side of the where clause to put a variable there. But if I had set times, so if I said I want to check these scripts every 24 hours, this once a week, this every hour, etc., I could actually duplicate all of these automations in such a way that one would trigger every 24 hours, one would trigger based upon the initial parameter. So when I create the tracker event, I could create a 24-hour tracker event, a 1-hour tracker event, a 1-week tracker event. So it is possible to do that. It's just, I figured I've already dumped enough on your brain right now that you probably don't care. So let's take a look at what's happened in my alarm system here. So we have one automation. So this is an automation that I just added. Now we have a bunch of built-in automations. One of the built-in automations says, go in and every 5 minutes delete normal or cleared events that are older than 5 minutes. Because this is my alarm list. I have 4 alarms. This tells me this is what I should be focusing on in my network. Now, I might have 1,000, 2,000, 1,000,000 events, but alarms this is my to-do list. So you want to make sure, I mean, when Chris was sitting here talking yesterday about you have no view of your network and then suddenly you have 10,000 alarms, they're both bad. I just spent a week in Dublin, and I was working with this guy named Patrick, of course, Patrick. They had like 1,500 alarms, and the first thing we did is we turned them all off. We dumped them, turned them all off, and then we went and said, okay, this one's really important, so we added it back. And then we tried to build the workflows in. If it's not actionable, if it's not something you take an action on, you shouldn't be an alarm. And so, as you can see, I've run my mouth really long, so we have our 2 tracking alarms. Now, in real life, I would acknowledge these alarms or set up another automation to automatically acknowledge these alarms because I don't want to see them in my list. But since this is live, I wanted you to see how this is kind of works. So I've got my tracking events. And now these are my failure events. Important script has not run. Another script has not run. Because it's been more than 3 minutes. So now in a knock situation, I'd be going, oh crap, another script didn't run last night, so I need to go fix it. And when you fix it, what should happen is you should get a script finished event. So let me send one of those. So there's my script finished event. So I should get, here's my normal script finished event. Now, what'll happen is, if you notice this time, the last event time is, this is still set to Eastern, this is New York time, so 4:23 in the morning. If you notice, where's my another script? This is set to 4:15. Now, there's our update automation is now running, so it's been 30 seconds, so I'll hit refresh. And you'll see that now the another script tracker, the time's been updated. And what this will actually do is cause the another script alarm to be cleared. Because there's an automation that says, oh, if the tracker gets updated, make sure that we go ahead and clear any outstanding alarms. And so within 2 minutes, what will happen is they'll all clear out. So, all the stuff with another script will clear out. And I can sort on severity just by clicking on that. And so I can keep all the important stuff at the problem. So important script hasn't run, but another script is now fixed. Is that cool? I mean, I'm a geek. That's cool to me. Because the beauty of it is I spent a lot of time configuring that one automation. But now, from here on out, I'm done. It's like all I got to do is go to my NOC and say, okay, guys, every time you run a script, run this Perl command, PHP command, Python command, etc. Send this information to OpenNMS, and it will automatically be tracked. I don't have to configure anything. I could make a 3rd script. I could make a 12 scripts. I could do a bunch of different nodes. And the automations will just work. Everything will run. Everything will clear out. And let me just to show that, let me go and acknowledge those 2. So I've got that. Now within, let's see, 23, just a few more. I've got everything set up pretty fast, so it'll be like 2 minutes. Come on. I want to make sure that goes away. Come on. There we go. So that one went away. The other one should go away in a minute. But basically, now my important script is running. So let's go and run that again. Make that go away. So now I got my normal event there. That'll clear out. And then this may take up to a minute because we have to update the tracker event and then we have to update the other alarm. The things you can do with automations, I was at a customer site and they were like, okay, well, we have this app that creates these 3 processes that I want to monitor. So we're monitoring these 3 processes, but he only wanted to know when all 3 were down at the same time. Well, you can write an automation for that. And again, this is all through configuration. I haven't had to write one piece of Java code. And anyway, I find all this to be, see, now we're all normal, and within 2 minutes, that'll clear, and my alarms will go away. Well, actually, one will come back because I have it set to check every 3 minutes. So I have to sit there every 3 minutes and send one. But anyway, that's kind of how that works. Again, I'm a geek. I find that exciting. You probably don't. So I've got 3 more minutes. So what's in the future? We're positioning OpenNMS for the Internet of Things. I really enjoyed the MQTT presentation yesterday because that sounds like something really cool. Part of it is we have a new project right now. Eric Evans, who's the primary person on it, is in Budapest at ApacheCon presenting this. So we have this thing called NewTS, which stands for New Time Series Database. This is a time series database like RD tool based on Cassandra. So you can do replication, you can do distribution, all of that stuff is there. On the developer's laptop, so the developers have these Mac Pros because they're evil, but they have these Macs. We were working with a data set of 7 billion data points. It was a weather data set that we got, and we were able to do it incredibly fast with NewTS. So NewTS is just a data storage thing. What we're doing right now is working on a strategy to implement graphing. So you'll be able to choose what graphing library you want. And then that should be integrated into OpenMS 15, maybe OpenMS 16, but I'm pretty sure it'll be next spring. We're going to come out with a NewTS version. And then you'll be able to store as much data as you possibly need in NewTS, which is kind of cool. We also have a project called Minion. Minion we've basically rewritten our remote data collector and made it a lot more intelligent and a lot easier to deploy. And basically, the idea is for localized data collection and intelligence. So it can do data collection, thresholding, event management at the local level, and then it forwards it up to an instance of OpenNMS we call Dominion. Get it? Minion, like the little yellow guys in Despicable Me. And so we have little minions. The actual working name of the Minion project was SNEPO, which is OpenMS backwards. It also stands for schnitzel and potatoes. So since we have a lot of German people working on our project, that was kind of funny. So anyway, and I honestly believe this is the first presentation I've ever finished on time. So you guys can go, you can say, I was there when Tarus stopped talking right when he was supposed to. This is me. My work blog is called adventuresinoss.com. My personal blog is called tarus.io. You can email me. We do have a Twitter feed called @OpenNMS, and I'm also on G+. I'm not on Facebook. I don't do the Facebook, but I am on G+. Thank you very much. I hope this was useful.